All right, so today we're on Unit 3, Lesson 4, and we have graphical features and terminology. You have a slew of new words to learn. So I would suggest that at the end of the video, I'm going to go back and we are going to write all these words down with a definition. But right now, I'm going to give you the graphical feature. I'm going to show you what they look like should they be graphed. And then the terminology we'll do at the end as like a vocabulary list. So the first thing we have over here is a graph. And we still have a little issue, but the graph, let's use this. This is the graph. This that looks like a bunch of mountains. And now I want to study things that this graph makes happen. So let's start off with the easy stuff. The easy stuff would be the first word we have to learn here, y-intercept. Where does my graph cross the y-axis? So as a matter of fact, right now, let's go and we are going to write this down, and this will be your first vocabulary. Y-intercept. Where the graph crosses the y-axis. All right, so let's go back here and let's look. Where does this graph cross the y-axis? So I'm going to, first off, let's get rid of this pink. And I'm just going to come over here with my highlighter. I'm going to use this. Here's my y-axis, and boom, that's my y-intercept. What number is that? 1, 2, 3, 4, 5, 6. So this is my y-intercept, and in this case it's the number 6. So now my x-intercept. Where does my graph cross the x-intercept? All right, so x-intercept, this is my x-axis. And I'm just going to ride along my x-axis so it crosses the x-axis in 1, 2 spots. So these are my x-intercepts. So I'm going to go back here to that page and I'm going to add another word to my vocabulary list. X-intercept. Where a graph crosses the x-axis. Now, we're going to leave domain and range to last. We have these other words up here. Relative minimum, absolute minimum, relative maximum, absolute maximum. Well, I'm going to go with the absolute maximum first. Have you ever have somebody tell you, absolutely not? That means no matter what, it's absolutely not going to happen. Well, an absolute maximum is exactly what it means. It's absolutely, no questions asked, the highest point of the graph. So let's see if I've got another highlighter pen. Yeah, I can use green. So this point right here is absolutely the highest point of the graph. So likewise, absolute minimum means the absolute lowest point of the graph. So the absolute lowest point of the graph is right there. So let's add those to our lists of definition. absolute maximum. And that means the highest point of the entire graph. Absolute minimum, the lowest point of the entire graph. Now, what does this relative minimum and relative maximum mean? That means we look for areas of the graph. So a relative minimum means we're going to look around an area. So when we look around, we want to go kind of where things start to bottom out. So in other words, right here is a relative minimum, because in this area of the graph, look, I made a smiley face. This is the minimum of this area. It also happens to be the absolute minimum of the entire graph. But this is more than one answer. There's also a relative minimum over here, because in this area of the graph, this happens to be the lowest value for this area. So I think you can see what happens with the relative maximum. Same thing. This is the absolute maximum of the graph, but it also happens to be in this area of the graph, it happens to be the highest point of this area. Likewise, getting a little crowded on this, there's a relative maximum right here, because in this area of the graph, there happens to be a relative maximum right there. So it's kind of like, well, you may not understand this, but in realtors, you never want to have the most expensive house in a neighborhood, because then it's the hardest house to sell. You don't have to be the most expensive house in the whole world, just in your neighborhood. So sometimes we refer to these as neighborhoods and what's happening around this neighborhood. All right, so give me a second. I'm going to clean up this whole graph so we can talk about domain and range. But before we do that, let's go back to that vocabulary page and let's write down our new vocabulary. So we have relative minimum, the lowest point in and I'll put it in quotes, neighborhood of a graph, and it's generally going to happen near a curve. And then the relative maximum. So it's the same as a relative minimum, except it's the highest point. In a neighborhood of a graph. All right, so now comes the domain and range word. Domain are the x values, or the input. Range are the y values, or the output. So that will be the last two words we're going to put into our vocabulary. Range. The y values, or the output of a graph. All right, so the x values. I'm going to get my pen, and let's see, let's use a highlighter. I'm going to draw a straight line, and that is x values. All right, so does my black graph cross this green line? It starts crossing it right here. So if I counted my x values, that's 1, 2, 3, 4, 5, 6, 7. That's -7. And it crosses every x value right up to that number right there. That's the last number it crosses. 1, 2, 3, 4, 5, 6, 7. So if I were to write the domain of this, I would say the domain is from 7 negative to 7 positive. And I'm using that interval notation. The range, if we remember, goes the other way. So I'm going to come over here and I'm going to get, I'm going to get a paintbrush. I haven't used a paintbrush yet. I'm going to use this purple, and the domain are lines that run horizontally. So this is the number what? This is the number -1, 2, 3, 4, 5, 6. My black graph doesn't cross -6 or -5 or -4 or -3 or -2. But wait a second, it does cross -1. So that's my lowest value in the range. And let's see what my highest value in the range is. Right there. That's my highest value in the range. 1, 2, 3, 4, 5, 6, 7. So I said that the lowest value in the range it crossed was -1, and the highest value that it crossed was +7. So that's how we figure out domain and range.